Now let's look at the factor theorems. If the remainder obtained from dividing the polynomial px by x minus a is 0, then the linear terms x minus a is called a factor of the polynomial px. If pa equal to 0, then x minus a is a factor of px. Now let's look at the example of the factor theorems. Find the remainder of x squared plus 2x plus 1 divided by x plus 1. You have two methods to find the remainder, which is the first one is by using long division and the second one is by using remainder theorems. For the long divisions, we're going to have x squared plus 2x plus 1 divided by x plus 1, and we're going to have x plus 1 as the quotients with the remainder 0. Now let's look at the remainder theorems. For the remainder theorems, we need to identify dx, which is x plus 1, and you can find that x equal to negative 1. So we can substitute the value of x equal to negative 1 in this polynomial. So we have p negative 1 equal to negative 1 squared plus 2 times negative 1 plus 1 equal to 0. So we have the remainder is 0. Therefore, x plus 1 is a factor of x squared plus 2x plus 1. You must take note that if x minus a is a factor of px, then pa equal to 0. And if ax plus p is a factor of px, then p, negative p over a, equal to 0. Example 1. Show that x minus 3 is a factor of px equal to 3 minus 7x plus 5x squared minus x cubed. Based on these linear terms, x minus 3, we can have x equal to 3. Then we can substitute x equal to 3 in this polynomial, which is we're going to have p3 equal to 3 minus 7 times 3 plus 5 times 3 squared minus 3 cubed equal to 3 minus 21 plus 45 minus 27 equal to 0. Therefore, we can say that x minus 3 is a factor of px equal to 3 minus 7x plus 5x squared minus x cubed. Example 2. By using remainder theorems, determine whether the linear functions dx equal to x plus 1 is a factor of px equal to negative 2x cubed plus 3x minus 6. Based on the linear functions dx equal to x plus 1, we're going to have x equal to negative 1. Now we will substitute x equal to negative 1 in this polynomial. So we're going to have p negative 1 equal to negative 2 times negative 1 cubed plus 3 times negative 1 minus 6 equal to negative 7. Since p negative 1 is not equal to 0, we can say that x plus 1 is not a factor of px equal to negative 2x cubed plus 3x minus 6. Example 3. If 2x plus 1 is a factor of polynomial px equal to 2x cubed plus px squared minus 5, find the value of p. In order to find the value of p, you need to form at least an equation. So to form that equation, we will consider this situation, which is 2x plus 1 is a factor of polynomials px. Once we know that 2x plus 1 is a factor, we know that the remainder will be 0. So we can form p negative 1 over 2, which is based on 2x plus 1 here, equal to 0. So now I will substitute x equal to negative 1 over 2 in this polynomial. So we have 2 times -1/2 cube plus b times -1/2 square minus 5 equal to 0. Next, we have 2 times -1/8 plus p over 4 minus 5 equal to 0. Next, we can have -1/4 plus p over 4 minus 5 equal to 0. I will rearrange these equations to have p over 4 as a subject. So I'm going to have p over 4 equal to 5 plus 1/4. So we have p over 4 equal to 21/4. Simplify, we get p equal to 21. Therefore, the value of p is 21. Example 4. Given that x minus 2 and x plus 1 are both factors of the polynomial px equal to 2x cubed plus ax squared plus bx minus 5, find the values of the constant a and b. In order to find the value of a and b, we need to form at least two equations. So we will consider the information that x minus 2 and x plus 1 is the factor of px. If the linear terms is a factor of px, then the remainder will be 0. For x minus 2, as the factor of px, we're going to have p2 equal to 0. And for x plus 1 is a factor of px, we're going to have p negative 1 equal to 0. So now we will substitute x equal to 2 in this polynomial. So we have 2 times 2 cubed plus a times 2 square plus b times 2 minus 5 equal to 0. So we have 16 plus 4a plus 2b minus 5 equal to 0. Rearrange, we're going to have 4a plus 2b equal to -11 be the first equations. Next, for x equal to -1, we will substitute also in this polynomial. So we have 2 times -1 cubed plus a times -1 square plus b times -1 minus 5 equal to 0. So we have -2 plus a minus b minus 5 equal to 0. Rearrange, we have a minus b equal to, I will bring -5 and -2 to the right hand side. So we get a minus b equal to 7 as the second equations. Next, I will take equations 2 multiply with 2. So we're going to have 2a minus 2b equal to 14 as the third equations. Next, I will try to find the value of a by taking equation 1 plus equations 3. So we have 4a plus 2a equal to 6a, 2b plus -2b, which is 2b minus 2b equal to 0, and we have -11 plus 14 equal to 3. So a equal to 1/2. Next, we will substitute a equal to 1/2 in equations 1 or equations 2 to find the value of b. I will try to substitute into equations 2. Substitute into 2. So we have a, which is 1/2, minus b equal to 7. So we have -b equal to 7 minus 1/2. Then b equal to -13/2. Therefore, a equal to 1/2 and b equal to -13/2. Example 5. When the polynomial px is divided by x squared minus 1, the remainder is mx plus n, which is we have Rx equal to mx plus n. Find the constant m and n. Give that x plus 1 is a factor of px, and when px is divided by x minus 1, the remainder is 4. Now the question asks you to find the constant m and n. In order to find the constant m and n, we need to form at least two equations. So first I'm going to take the divisor here, which is x squared minus 1, and we are going to factorize that divisor. So we have dx equal to x squared minus 1 equal to x plus 1 times x minus 1. For x plus 1, we are going to refer to this information, which is x plus 1 is a factor of px. When x plus 1 is a factor of px, the remainder will be 0. We're going to have from x plus 1 here, we can write x equal to negative 1. So when x equal to negative 1, p negative 1 equal to 0, since x plus 1 is a factor of px. Next, for x minus 1, we are going to refer to this information, which is when px is divided by x minus 1, this is the divisor, the remainder is 4. Since we have the divisor x minus 1, x will equal to 1. So p1 will equal to 4 since the remainder is 4. Okay, now we know that if you have p negative 1, it will equal to r negative 1s. So I'm going to substitute x equal to negative 1s in these equations of rx. So we're going to have m times negative 1 plus n, and p negative 1 is equal to 0. So 0 equal to m times negative 1 plus n. I will rearrange these equations to be negative m plus n equal to 0 as the first equations. Next, for p1 here, it will be p1 equal to r1. So for r1, I'm going to substitute x equal to 1 in these equations. So we have m times 1 plus n. For p1, we have 4 here. So p1 equal to 4. So we have 4 equal to m1 plus n. Rearrange these equations. We have m plus n equal to 4 will be the second equations. Next, let's try to find the value of n by taking equations 2 minus equations 1. So we have m minus negative m equal to 2m, and n minus n equal to 0. Next, 4 minus 0 equal to 4. So m equal to 2. Now I'm going to take this value m equal to 2 to be substituted into equations 2 to find the value of n. So we have 2 plus n equal to 4. So n equal to 4 minus 2 equal to 2. Therefore, we can have the value of m equal to 2 and n equal to 2. And you can also write rx equal to 2x plus 2. Example 6. Given that the expressions bx equal to 3x cubed plus ax squared plus bx minus 12 is exactly divisible by x squared plus 2x minus 3. A. Determine the values of a and b. B. Hence factorize the expressions completely. Now let's answer questions A. To find the values of a and b, we need to form at least two equations. First, you must note that this polynomial is exactly divisible by this divisor. That means the remainder will be 0. Next, we will let dx equal to x squared plus 2x minus 3, and I will factorize these quadratic expressions. We will get x minus 1 times x plus 3. For x minus 1, we're going to get x equal to 1. By applying the factor theorems, we know that P1 equal to 0. And for x plus 3, we're going to get x equal to negative 3. By applying also the factor theorems, we get P negative 3 equal to 0. Next, I'm going to substitute x equal to 1 in this polynomial. So we get 3 times 1 cube plus a times 1 square plus b times 1 minus 12 equal to 0. Simplify these equations. We get 3 plus a plus b minus 12 equal to 0. So a plus b equal to 9 as the first equations. Now let's substitute x equal to negative 3 also in this polynomial. We get 3 times negative 3 cube plus a times negative 3 square plus b times negative 3 minus 12 equal to 0. Now we're going to simplify these equations. We get negative 81 plus 9a minus 3b minus 12 equal to 0. So we get 9a minus 3b equal to 93. I'm going to simplify these equations by dividing these equations by 3. So we get 3a minus b equal to 31 as the second equations. Now let's try to find the value of a by taking equations 1 plus equations 2. So we have a plus 3a equal to 4a. Next, b plus negative b will equal to 0. Then we take 9 plus 31 equal to 40. So we get a equal to 10. Now we can take a equal to 10 to be substituted into equations 1 or equations 2 to find the value of b. I will choose to substitute into equations 1. So substitute into 1, we're going to get 10 plus b equal to 9. So b equal to negative 1. Therefore, a equal to 10 and b equal to negative 1. And I'm going to write this value of a and b in this polynomial because we are going to use letter in questions b. So we get px equal to 3x cubed plus 10x squared minus x minus 12. Now let's try to answer questions b. Factorize the expressions completely. In order to factorize the expressions completely, I'm going to apply the long division. So we're going to take 3x cubed plus 10x squared minus x minus 12 divided by the divisor x squared plus 2x minus 3. Now let's try to eliminate 3x cubed, which is I'm going to take 3x multiply with this divisor. We're going to get 3x cubed plus 6x squared minus 9x. So next we take 3x cubed minus 3x cubed equal to 0. 10x squared minus 6x squared is 4x squared. Negative x minus negative 9x equal to positive 8x. So we get 4x squared plus 8x. Now bring the remaining terms below here. we get minus 12. Next, try to eliminate 4x squared. So I'm going to multiply 4 with this divisor. So we get 4x squared plus 8x minus 12. So we take 4x squared minus 4x squared, 0. Add 8x minus 8x, also 0. Negative 12 minus negative 12, also 0. So the remainder is 0. Now you need to write the polynomial here in this form, which is px equal to qx, which is 3x plus 4 times dx, the divisor, x squared, plus 2x minus 3 plus the remainder, which is plus 0. No need to write here. Next, we need to factorize the divisor here. So we get 3x plus 4, and after you factorize the divisor, we get x plus 3 times x minus 1. Therefore, px equal to 3x plus 4 times x plus 3 times x minus 1.